Actually, every block in MimbleWimble is just one big coin join. So we get that privacy improvement there for free. And in addition to those fancy privacy features, you also have the scalability. For traditional Litecoin, in order to validate the blockchain, you have to download every transaction in history. With MimbleWimble, you don't need all that old history. You do still need parts of a transaction. So it's not like an exponential improvement on scalability, but it's about a third or a quarter of the size initial block download.
Hey everyone, I have the fantastic pleasure of speaking with the one and only David Burkett. How's it going, man?
Good, how are you?
I'm doing pretty great. I've been meaning to talk to you for quite some time now because for the longest time, it seems like on the whole, Litecoin's development roadmap was very Bitcoin based, whether it's backporting and things like that, or whether it's doing some things earlier than Bitcoin like SegWit. And when I kind of heard about MimbleWimble and the whole boom of whenever that was, when Grin and Beam and all them came out, and it seemed like I didn't investigate too much at the time, and then there was like a little bit of a flash in the pan, like a lot of hype, and then people stopped talking about it abruptly, and then I saw, of course, that it was coming to Litecoin, and that kind of piqued my interest, and since been kind of poking around in the background, kind of investigating, looking at stuff, downloading and using some MimbleWimble wallets for other cryptos and things like that, and experimenting around. And so it definitely something that I think it piques my interest, and it's definitely one of the more unique value propositions, I guess, for Litecoin. So I wanted to I had basically questions I couldn't answer on my own, so I decided to reach out. So real quick, would you mind just quickly introducing yourself and what you do?
Yeah, so David Burkett, I'm the lead developer for Litecoin. We had the MimbleWimble extension block project went live a year ago. It's like a 2 or 3 year project, and so I've just been supporting it. I mean, I also do a bunch of things around mining and other stuff, but we're here to talk Litecoin. So MWEB is my main focus when on Litecoin. We have it live it's been live for a year now, but we have very little usage because we lack some of the like infrastructure needed for using it in light wallets and mobile wallets and those sorts of things. So I'm currently focused on trying to gain adoption to backfill some of those more useful features.
Yeah, so would you mind really quick explaining what MimbleWimble is and how is it different from like a standard blockchain architecture like a Bitcoin or Litecoin regular chain?
Yeah, so normally for regular transactions on Bitcoin or Litecoin, you would have like when a transaction is it's like a pointer to old transactions, to old coins on the blockchain that have been unspent, and those are called like your inputs. You just like say, hey, I own this input that has say 10 Litecoin in it, and it was sent to this address that I know, I know the key for. And so you can gather a bunch of those up. Say you have one with 10, one with 5, whatever. And then I want to send you, say, 12 Litecoin. So then I create a new coin on the chain that sends 12 to you, and then sends the rest back to myself as change, right? And so with Bitcoin and Litecoin, the addresses for all that are all public. If you reuse an address, you can see all the outputs, all the old coins that belong to the same user. You can see all the transactions they were involved in. Everything's public. You can see how much is in that wallet. If I spend, say I have $1 million in my wallet and I buy $6 worth of coffee from you, depending on which coins my wallet chooses, when buying that coffee, you could find out that I have $1 million on my wallet just by buying a $6 item from you. So all this stuff's public because you basically open up your wallet with the transaction, you pull out some bills, and then you send some to you, and then the rest back to yourself as change. So it's all very transparent, which makes it auditable, which makes it secure, which is makes it work. But it isn't very practical, and it's there's some dangers with that kind of radical transparency in your
Yeah, of
day-to-day
course.
financing. Nobody wants to be advertising how much they have when they're walking down the street. So what MimbleWimble does, it's two parts. It's part scaling, part privacy. On the privacy part, what it does is instead of the amounts being all transparent, there's just like this zero knowledge proof that commits to kind of the sum of the coins in there, and the amounts of everything are not known. It's just there's some fancy zero knowledge stuff that we can obscure the amounts. It's called confidential transactions if you're interested in learning more. Um, but in addition to that, there's a couple different things. There's also a we use stealth addresses. So instead of just your address being tied to each of your coins on the blockchain, you instead use a stealth address. So each new coin, each new transaction is generated to a completely fresh address. There's no reusage of them or anything. Um, so you can't go link your old transactions easily together like that. And then there's also a coin join. So for people who are not familiar
Hmm.
with CoinJoin, it's basically, um, you have those transactions I mentioned, which is me pointing to old coins I own, sending them to new coins. Um, what a CoinJoin is it takes a bunch of different people pointing to their old coins and sending to new coins. It basically just joins a bunch of transactions together to obscure whose coins are going where. Um, And so actually every block in MimbleWimble is just one big coin join. So we get that,
Hmm.
that nice privacy improvement there for free. And in addition to that, so all those fancy privacy features, you also have the scalability, which is when you spend a coin in MimbleWimble, well, for traditional Litecoin, in order to validate the blockchain from, say, you want to download uh, the Litecoin blockchain from scratch, you have to download every transaction in history, like the
Hmm.
full transaction, and you have to verify it. Um, with MimbleWimble, when you spend an output, you can actually prove that. You don't need it anymore to validate it because it's like a big fancy sum.
Yeah.
It's this fancy like just um, addition of a bunch of elliptic curve points. And when you spend like the inputs cross out outputs, so like if you spend coins, it can like completely erase that from the big sum, and so you don't actually need all those old coins.
Mm.
You don't need all that old history. You do still need parts of a transaction, so like it's not perfect. You still need a small portion called the kernel, transaction
Mm.
kernel, which is about 100 bytes. So it's not like an exponential improvement on scalability, but it's about three to four, well, I guess like a third or a quarter of the size
Hmm.
initial block download. So the initial download of a blockchain could be reduced quite significantly due to only needing small parts of transactions to verify the current state of the blockchain. So yeah, it's just a really big, fancy. It really it's like tying together a bunch of old technologies um,
Mm.
that all the smart people like Greg Maxwell, Adam
Hmm.
Back, all those people back in eons ago, back in like 2012, 2013, when Bitcoin was young, they were working on all these different ideas with confidential transactions, coin joins, all these different things, and it's kind of like ties a bunch of the big ones together in this really neat, like efficient protocol for adding privacy and scalability in one.
Yeah. It's so. It seems like it's It's like a coin join, but with some extra privacy improvements because you don't have amounts or addresses really,
Hmm.
and then you prune a whole bunch of data so you don't need to keep that on the blockchain forever. And so that's
Hmm.
kind of like the quick overview of what it
Hmm.
sort of turns out
And
like.
yeah, and one caveat. So it's not just a coin join; it's a non-interactive coin join, which is huge.
Mm-hmm.
Because right now the problem with using a coin join is you have to like you need a man in the middle. You need to like
Mm-hmm.
wait for rounds to take place and all this stuff, and you have to.
Yeah.
There's all this coordination to get all the parties to work together to build one big transaction. Instead, with this, you just build your transaction, and then
Mm-hmm.
when it's added to the block, it's joined with all the other ones. Yeah, so it's kind of cool in that sense.
Yeah. And so obviously, when you prune the data, it doesn't, or when you don't store the data, rather, it saves storage space long term. Does it store? Does it save bandwidth in the immediate term? Like, are these actually like later transactions to send around for like nodes to broadcast and things like that, or are they about the same, or maybe are they larger?
So the transactions themselves are much larger.
Mm-hmm.
They're close to. I have sizes here somewhere.
Mm-hmm.
I'm kind of bad with notes, but something like two kilobytes or something. It basically depends how many outputs, which traditionally there's like two outputs in a standard
Mm-hmm.
transaction. Inputs are rather small, but yeah, it ends up being 2 or 3 kilobytes for a transaction, as opposed to maybe 700 or 800 bytes for Litecoin right now,
Mm-hmm.
average. I don't know the average, but I'm guessing somewhere in there. Um, but then when it becomes all, when it's all spent and stuff, like historically, that ends up being then about 120 bytes you need to keep around. So it's quite a bit smaller piece you have to keep around. But for like, if you're like keeping sync with the current chain, and each new
Mm-hmm.
block that comes in is, the transactions on those, the MimbleWimble transactions are, several times larger.
Yeah. How does it work with like SPV or light wallet kind of architecture? Because if you run like a, for the viewers at home, right? When if you run like a light wallet, like a regular mobile
Hmm.
wallet, you don't need to download the entire blockchain of whatever to do it. And now is it but that's also because it's like transparent and it's easy to just get like block headers or something
Yeah,
like that.
it's terrible for privacy. You basically say, "Hey, I own these addresses. Can you give me everything related to
Yeah.
that?" And there's some probability mixed in, but as we've learned over the years, this actually is terrible.
Mm-hmm.
When like the original, not the original SPV, but the actual SPV we implemented in Bitcoin turned out to be very, very terrible for privacy. We pretty much are just advertising our addresses to some trusted server who then has the whole blockchain history and goes and looks up everything related to us. And we just trust that they give us everything too. There's all these
Mm-hmm.
issues. We don't have, well, so there's some, there are options
Mm-hmm.
for SPV. So we can use something called a view key, which would basically then bring, revert your privacy at least to, in the eyes of like the central server. If you have a trusted central server, you could give them a view key, and they could look up all of the transactions that you've ever been involved with,
Mm-hmm.
and give you that, just like today. But they, then they learn all the transactions you've been involved with, right?
Of course.
And if you're using MWEB, presumably you care about your privacy, or at least maybe you don't care for the central server, but other people. It depends. It depends what your use case is. But there's some other options we can. We've implemented for version 24 of Litecoin a new syncing process for Lite clients, where they can download like little bits of of the extension block, um,
Mm-hmm.
to get, well, basically you have a UTXO set, so like
Mm-hmm.
unspent outputs, and you can download small portions of each one and identify from that using your private key whether or not it belongs to you, and then you can go request it from someone else or whatever, the full transaction. But yeah, you basically have different options, and there's like, each comes with a little trade-off. Do you want to, it's either downloading more data, like right now you don't have to download really any transactions for SPV except the ones related to you. But for this would involve downloading, maybe 1% of the blockchain or something to then go through all the outputs and see if they belong to you. So it's more flexible in that sense. We can either use the view key, like which is just reverting back, um, or we can have anywhere in between those two. There's various different options of how you can sync it to to get your to get your transactions. But each comes with their own kind of trade-offs. So
Yeah. So in general, what are the kind of trade-offs for MimbleWimble versus like the blockchain architecture? Seems like mostly we've talked about a lot of like the benefits, meaning that it's like, you
yeah,
know, and then so
so
what are
like
some of
this,
the trade-offs? Like why would you want to have a transparent regular side of Litecoin and not just move all of Litecoin to MimbleWimble, for example?
right. So size we mentioned, current transactions like being broadcast are quite a bit larger. So that's a trade-off there. You have they're a little more limited scope. Our version actually isn't too bad for Litecoin. Pure Mimble, we're not pure Mimblewimble. I made some
Mm-hmm.
adjustments. Um, Pure Mimblewimble doesn't have scripts. It doesn't have like fancy smart contract options.
Mm-hmm.
However, they have Andrew Postra and others have developed something called scriptless scripts, which kind of
Mm-hmm.
allows you to just takes advantage of the properties of Schnorr signatures to kind of like um, to to implement some kind of scripting functionality off chain, basically.
Mm-hmm.
Um, but there's yeah, there's a lot more complexity involved. So anytime you lose transparency, it's not as transparent. So let's say there's
Yeah.
an inflation bug, something like that, which is very unlikely. The crypto primitives we use are fairly simple as far as zero knowledge proofs go. Um, but you always have the risk of um, some kind of undetected inflation bug, which would go on far longer on a private chain. You have yeah, it's just it's quite a bit different than
Mm-hmm.
Bitcoin transactions. So like all the frameworks, all the third-party wallets, all the everything that exists basically for the last 11 years of Litecoin's life is not really compatible with transacting via MWEB. So um, it's possible that someday maybe we would 20 or 30 years from now move to MWEB purely, um, but you know it's a huge change, so it's
Yeah.
the trade-offs are the lack of basically available services that interact with it, the larger size transactions, and the greater complexity of protocol.
Yeah, and about the transaction size thing. So it seems like it is to a certain extent from a scaling solution sort of a standpoint. Doing MWeb transactions makes it easier to, because the blockchain is smaller over time, right? The amount the
Hmm.
node has to sync, but it might make it harder if there's a lot of volume going through it because
Yeah.
individual transactions are bigger, and then for propagation and et cetera, it might be a little trickier.
Yeah. It. I had verification times. My notes are a mess. But somewhere in here, I have verification times of like a full block. Um, and it's quite a bit larger than like quite a bit longer to validate a full MWeb block versus just a full Litecoin block. Like if
Mm-hmm.
you had all the transactions in there and you had to go validate all the signatures, all the zero knowledge proofs, yeah, it's not great for scaling currently. Like
Mm-hmm.
for scaling like current transactions,
Mm-hmm.
validating on the go. But it's a lot better than a lot of the privacy coins out there. Like so, the
Yeah.
Monero approach is awful for scaling. They have it's basically for every like input you have for every old coin you're spending, um, you end up with a huge ring signature because which like you basically sign a bunch of different old inputs for each input, and it it ends up being massive transactions. I don't know the exact numbers, but like I don't know what the average is anyways, but it can be 10, 20 kilobytes for a single transaction, maybe even more depending on what you're doing with it. There's all these different ways of implementing privacy, and a lot of them are way worse for scalability. And there's some that are better for like scaling for transaction sizes and stuff like
Mm-hmm.
Zcash, but Zcash comes with incredible complexity at a
Oh
protocol
yeah.
level.
Yeah.
The
I've been
12 scientists or whatever in the world that can understand it, let's put a lot of faith in them.
Yeah, I've been using Zcash pretty heavily for over the last year or so, and there's been some wallet challenges to say the least with stuff.
Yeah, they always have challenges just due to just I mean what they did was pretty groundbreaking. I mean it's
Mm-hmm.
impressive stuff. They I love the Zcash team. They've really pushed the privacy space forward in the terms of what's possible. But I don't know that for my daily money I want to use like the cutting edge, like this
Mm-hmm.
is the latest research, crypto, whatever. Um,
Yeah.
it just seems a little risky to have at least your net worth wrapped up in it. But um, yeah, they are doing some really cool stuff. But definitely, like I said, the complexity is unreal, and trying to audit that kind of thing is not
Yeah.
easy.
That definitely makes sense. So another thing I heard about, but I've heard some conflicting things about, is the kind of always on sort of nature of MimbleWimble, meaning that I've heard some people say you have to be online to receive a payment, for example, and I've heard other people say the opposite. That you know. So do you mind just breaking down how that works and clearing up the confusion on that?
Yeah, pure Mimblewimble, you absolutely have to be online to receive transactions. It's an interactive process where wallets will build the transaction together. There's like
Mm-hmm.
three-step process to sign the transaction in a way that you know gives us all these properties of Mimblewimble. Um, for MWEB, I came up with an idea for doing non-interactive transactions. It comes with some minor like security trade-offs, not practical ones, just like purist ones. But
Mm-hmm.
there's like uh, someone who has access to an extreme amount of hash rate and wants to do like a 2 week reorg can
Mm-hmm.
take back like transactions they sent. It might even be more than that. It might be more like a 2 month reorg. Can take back transactions like they previously sent to someone else that were then unspent. Like it makes it so there's this weird, like protocol imperfection. It's just like the OCD people out there like me um, are a little annoyed by it, but it's from a practical standpoint, if you can reorg 2 months of the blockchain's broken anyway. So there's it's not making things any worse practically
Yeah, of
speaking,
course.
because 2 month reorg will destroy whatever.
Mm-hmm.
Um, but yeah, there's like this. There's an impurity in the security trade. The security. I don't know what word I'm looking for. It's like you said, it's early.
Mm-hmm.
um, but there's other than that though, there's you know we basically maintained all the same. What did you last hear? Sorry. Uh,
Um,
did it?
it just missed like 5 seconds or something.
Okay.
You're
All
talking
right.
about, yeah. I can't even remember at this point, but
Okay. Yeah. Yeah.
mm,
Um, so we maintain the same properties of MimbleWimble, the important
mm-hmm.
properties of MimbleWimble, but we were able to implement the stealth address feature I mentioned,
Mm-hmm.
which no longer requires you to be online to receive your transactions. So for MWeb, for Litecoin, we do not have that limitation. But for the
Mm-hmm.
original Mimblewimble protocol in its purest form, as implemented like on Grin,
Mm-hmm.
yeah, you have to be online, and it's a real pain. I mean, Grin doesn't work very well at all for
Yeah.
and maybe with some time, like there that can improve. Like Beam did a better job at it,
Mm-hmm.
of like making transacting easier, but it's just a huge engineering challenge. Like making online wallets for everything, like just function well, communicate well, everything. So yeah, like one of the bigger problems with Grin was that online feature, um, and so we got rid of it. We thought we were going to have to use it first with MWEB, but luckily I was able to figure out a way along the way to do non-interactive, and it's much easier.
Nice. Well, let's talk about the extension block thing first. So, think about. I think there's not a lot of like general knowledge out there about what an extension block is, or how does it work, or can it be soft forked in, or what does that do with for miners and nodes? Do they have to choose which ones they do? All that kind of stuff. So, would you mind just going over really quick how extension blocks as like a whole work?
Yes.
At least
Blocks,
in this soft fork kind of implementation kind of thing.
Yep. So a soft fork, there's certain things you can soft fork into a protocol pretty easily. SegWit turned out to be not easy, but easier than something like MimbleWimble, which is a complete restructuring of how a transaction is, what a transaction is. It's not something you can simply soft fork in the traditional way. In order to do a soft fork, and soft fork, just to clarify, it just means old nodes will still accept the blocks that are from like a newer soft forked protocol, as opposed to a hard fork where old nodes won't accept those blocks and you end up with a chain split. So in order to soft fork in something like MimbleWimble, we have to use something called these extension blocks, which is basically an additional block for every block. So you have your main block with all your normal transaction, you have your Coinbase transaction, and then all the other transactions. And then you have this additional block that has a different set of rules, the MimbleWimble set of rules. So what we do then with extension blocks is the last block, or the last transaction in the traditional block, is like a commitment to this new block. So like it's like a proof of the entire new block. Like it says, hey, this one is involved, and then coins that are transacted on this new block, that last transaction will actually like move the coins from the traditional Litecoin side into some special address, which kind of like we call it pegs into the extension block side, to the MimbleWimble side. So it's like just a whole new block. So for every single block of Litecoins since the time MWEB activates has an additional block with it, in a completely different format, different validation rules and everything. That's where MimbleWimble is. That's what the MWEB is. And then we just have the last transaction in the block is like kind of a proof of all the coins in there and all the everything. So yeah, so it's just like a second block that trails along with each one. Yep.
Yeah. And so if you run a regular old Litecoin node that doesn't accept this kind of thing, when people are moving in and out of MWEB in there, what do you see?
You see one really rich person with lots of coins on the last transaction of every block, but it turns out that rich person is just the MWEB block. So all the MWEB coins, any coin that's being transacted on the MWEB, just shows up in this transaction in the block, but you don't get any of the actual second block. You don't get any of the MWEB data there. You don't validate any of that. You don't know anything about it, which is a lot like SegWit. SegWit is a separate. So currently, the way transactions are committed in Bitcoin and Litecoin is you have a Merkle proof, all the transactions in there. SegWit is additional Merkle proof of all the witnesses in there. And so if you don't have an upgraded node, you don't have all the witnesses. You don't get to see all the signatures and things like that. And so, it's just, you just get part of the block. And well, this is the same way, where you just don't get the extra block with all the MWEB data. You just validate the old transactions.
Yeah. And so, for example, if there's a bunch of MWEB users, it just looks like a one person instead of a bunch of users having all those funds. And how does the pegging in and out kind of work from the, I guess, like the user perspective?
From the user perspective, users don't have to think about it at all. We automatically um, we automatically decide and figure out in the wallet side when there are enough of their coins on the MWEB side or on the Litecoin side to make a transaction, and when there's not, we automatically then move them as part of that transaction. So
Mm-hmm.
when you create a single transaction, and you might think you're just sending from your wallet to an MWEB wallet, but you could be moving Litecoin coins into it, pegging into the MWEB, and then moving them. There could be many different things. Or you might think you're just sending to a traditional Litecoin address, but instead it's actually taking MWEB coins that you have pegged in already, pegging them out to that address. So, we kind of handle everything behind the scenes.
Mm-hmm.
But basically, in order to transact with coins, you've got to have the coins on the right side, on the
Yeah, of
MWEB
course.
side or on the Litecoin side. And so the pegging in out just kind of handles that.
Yeah, and so how many confirmations do you need before your your coins could be considered in MWeb? Is it just like the very next block, like one?
For peg ins,
Yes.
yeah, it's no different than current. For peg outs, it's a bit different. We require 6 confirmations
Mm-hmm.
because uh, if you if you peg out to yeah, if you have like if someone pegs out coins to your address, and then you see that coin on the blockchain, and then you go to try to spend those, um,
Mm-hmm.
and then you broadcast your transaction spending those, and then there's a 1 block reorg. That
Mm-hmm.
old coin like it doesn't exist anymore. It kind of changes, like, because each peg out, like each MWeb block, each like we call it integrating transaction. It's that transaction at the end of the Litecoin block. If it changes any, then any transactions built after that have to be updated. And
Mm-hmm.
so like we don't typically see that with Litecoin because you can just like rebroadcast all the old transactions or whatever. But we have that Coinbase maturity rule, right?
Mm-hmm.
And the reason for that is, like, let's say you tried to spend a Coinbase that was just, you just mined a block 1 block ago, try to spend that Coinbase, and then it gets reorged out. Well, then that new transaction is no longer valid. It's a similar principle for pegging out coins, where, um, if you immediately tried to spend a peg out coin and there was a reorg, then the transaction you just created is no longer valid, and you have to recreate it. So we require, when pegging out, six confirmations before those coins can be spent. But pegging in is very simple. It's just like normal transact.
Yeah, and so with the pegging in and out, is that only in your own kind of wallet and your keys, or could you, for example, if you have only MWeb coins and I only have regular ones, could I just
Mm-hmm.
send you some and then you receive them into your MWeb thing and like one
Mm-hmm.
confirmation later,
Yep.
and then vice versa as well?
If you have MWeb and you send it to you, you could receive them 6 confirmations,
Mm-hmm.
because that would be a peg out. But
Yeah.
but yes, pegging, when you peg in, when you send from your Litecoin to my MWeb address, yes, I would receive that in
Mm-hmm.
1 confirmation. Yep.
Yeah, and so we're talking about compatibility, right? Because
Mm-hmm.
uh, obviously the crypto world works really slowly sometimes as far as the ecosystems. Everything's very, if you're a Bitcoin based coin, for example, you're much more likely to be integrated into a service because just how easy it is, for example.
Mm-hmm.
But so one thing that Zcash did in the very early days that has been a source of controversy, but also has been a source of, who knows if it's a good idea or not, but is the transparent address thing for pure compatibility reasons. Because otherwise, no one will be able to even touch Zcash. And then, so
Mm-hmm.
then they have the shielded and transparent types. And so basically, because of that, there's nowhere that Zcash is accepted that you couldn't interact with if you have the shielded funds, even though you might lose some of the privacy by unshielding.
Mm-hmm.
So is it kind of the same thing with
Mm-hmm.
the MemWeb? So let's just say you're a MWeb maxi, you just love the privacy. You and your 5 people you transact with on a routine basis are all doing this. But then you go out to the world, and then you go to like Bitrefill or something, and then like Bitrefill might not take, just regular Litecoin, not MWeb, and so you can just go pay a Bitrefill invoice from your MWeb account, as it were, your wallet, and then it just works kind of as normal. Is that kind of correct? Except that they have
exactly
to wait
right.
six confirmations before moving.
Yeah, which everybody waits anyways.
Yeah.
For 6 confirmations not very long on like what 15 minutes, something like that. So, but yeah, there's not much difference. It's pretty much the same thing as what Zcash has with their shielded, which if you're interacting with a regular Litecoin address, you're going to lose some privacy there.
Yeah.
But the privacy is not perfect anyways on MWeb. There's it's like an excellent, huge improvement over Bitcoin, but it's not perfect. It's not Zcash. And so people need to be aware of that anyways. You're never perfectly private when using MWeb, or really ever perfectly private when using any
Yeah, of
any
course.
blockchain or anything. But it's a very, very good step in the right direction. Um, yeah, so.
Yeah, so what are the privacy, I guess, considerations or trade-offs of interacting between those two worlds? So, like, for example, like if you, for the Zcash example, right, if you send a shielded transaction to a transparent address, then it'll just, for all practical purposes, come from the sky, and you'll see where you see where it goes, but you won't be able to see where it came from unless you do some analysis and time that someone went into the shielded pool and the same amount went out, and that kind of. Is it basically the same kind of a thing, or is there other data that kind of links, or what?
Yes, it is. It is basically the same thing, except for like the analysis you can do is you can do a lot more analysis on MWeb. You have a much better chance of finding some kind of path through there or something. It's not like a pure like just dropping from the sky kind of thing. Um, you know, it's you see coins coming from the MWeb, and you can see like that. It's a less pure version of it. I don't know a very good way to explain it, but yeah, you when you transact on MWeb, all the amounts are hidden, they're all private, and the like you don't have it's not easy to link outputs to inputs throughout it. But like if you let's say I immediately peg in 10 Litecoins, and then like 1 block later I peg out 10 Litecoins, like you're gonna know where that came from, right? Or 100 Litecoins, whatever. If you are constantly moving back and forth between MWeb, you're not going to really get any of the privacy advantages. The advantages come from two things, which is being in the MWeb and transacting in the MWeb and staying in that like container as long as possible, but also having like lots of other transactions in there too. A larger anonymity set is necessary to really benefit greatly from the privacy of that. So the more users using MWeb each block, the more transactions to hide. And yeah.
Yeah. Now, as far as actual like MWeb nodes and things like that, I assume it's just a certain version of Litecoin Core onward would have MWeb in it. Which version is that? Do you remember?
Yeah, 21.2.1. 21.2.1, I think is it. Yeah.
Interesting. It's so.
Or maybe it's just 21.2, but we definitely have a couple of like minor versions in afterwards. Yeah.
Yeah, I'm looking at crypto ID info, and there's 21.1 and .2 that shows up on their Node Explorer. But I'll do some other poking around offline there. But so basically, those are the nodes that are running, for the most part, that are running MWeb as well. And so it's going to be, it seems like it's probably a small minority of nodes at this point, right?
I don't think so. It's probably close to half anyways. Here we go. It's loading. 1 second. We are now we're way more than half. So
Nice.
we have 48, 175, 606 out of 945 on block chair.
Mm,
So almost 2/3
yeah,
are admin compatible.
that's nice. So I guess I'll just stop using Crypto ID because I like BlockShare's Node Explorer a lot better anyway. Um, yeah, so then that's kind of the number of nodes that will be transacting. So like obviously the people talk, at least it seems to be when the MimbleWimble original paper came out and Grin came out and all that kind of stuff, one of the hype killers of that time, because it had a ton of hype and then just completely disappeared. Seems to have been like the sniffer node kind of a problem, where you have some nodes that show up and then people seem to have read that and just said, it's broken, we're not going to touch it. Just like the
Well,
hype moved on, you know?
it's crypto. We all
Yeah.
pretend to be in it for the check, but there's very few that
Yeah.
actually are. Um, what that Ivan's analysis was not groundbreaking at all.
Mm-hmm.
It was not a surprise at all. It was not
Yeah.
even like news to me.
Mm-hmm.
But at the time, it ended up being very, very big news. Very big effect on me because basically a bunch of people jumped off the Mimble wagon immediately. It was an
Mm-hmm.
unfinished. I mean, it was still in progress. It was a barely used blockchain.
Mm-hmm.
Okay, so you had like a couple transactions per block, and he's like, "Look, I can link these transactions." Like, yes, you're sniffing two transactions,
Mm-hmm.
per block, and like we have no privacy because it's not being used. You can never hide in a small crowd. You can never hide. It doesn't matter what. Like if 5 people are using Zcash, like
Mm-hmm.
it's not very useful, no matter how perfect the technology is. And so like all he did was explain how MimbleWimble worked, basically in his big paper, but he did it in this
Scary kind of
Hollywood
way.
style way. And so everybody just panicked and freaked out, whatever.
Mm-hmm.
But I don't think that's really what killed MimbleWimble. That was maybe like the final nail on the coffin. But like Grim didn't take off because for two reasons. The interactive transactions suck. They're awful to use.
Mm-hmm.
They didn't work. No exchange wanted to include Grin because it, it's hard to use, and there's a lot there. And it's not just a protocol problem. They have some implementation issues, um, and so like it's something that could have been solvable. Uh, but like no exchange kind of wanted to touch it because it came with a huge headache. But another thing was just their mission and stuff. It's really really hard. They tried to do a super fair launch, like
Mm-hmm.
probably the fairest ever. Um, uh, I know it is. It's got to be the fairest launch ever because it's like there's no like upfront coins. It was all like just like
Mm-hmm.
Bitcoin and Litecoin, where it's like there's no VCs, no investors like getting a share of the coins. It's every block or whatever gets so many coins. They tried to do like instead of just a pure like tail emission kind of thing like Monero, they don't front load any of the coins. Like it's
Mm-hmm.
one coin per second forever. It ends up being like not a very good investment,
Yeah.
because it does. There's no reason to like rush into it now to get a bunch of coins with the expectation it's going to go up in value,
Mm-hmm.
um, because they're just going to keep 50 coins every block, and so like um, it ended up just being a terrible investment, and if something isn't making someone money, it's going to die in crypto pretty quick.
Of course.
That's it. Like I said, we may pretend to be in it for the tech, but if something's going, if something can't make someone money, nobody's interested. So you're going to be building it for yourself anyways, even if you are interested in the tech, because most people are here to make money, for better or worse. I think worse. But
Yeah.
so Grin really died. It died off. It's not dead. It's still going. They still do cool
Mm-hmm.
stuff. But it lost its hype just simply because nobody can make money off of it. Nobody can get rich
Mm-hmm.
off of it. So you don't have the few early investors pumping a bunch of money into marketing and things like that. There was no marketing budget. There was no budget for anything. Um, and so, yeah, it was a neat like experiment on can we still do a Satoshi style launch of a new cryptocurrency? And the answer is no, we can't, not successfully. Uh,
Yeah.
you pretty much just have to have a VC launched like scam coin that has, front loads 75% of the supply, so those VCs can pump up the price, 100x to get people interested, whatever. Um, and yeah, it's a shame. The Satoshi days are over. Litecoin was one of the last ones that had a successful, fair launch. Um, and yeah, so yeah. Long story short, the MimbleWimble days, like MimbleWimble was very, very, very overhyped for what it was. People assumed it was like perfect privacy and scalability. Um, and it's instead a scalability improvement and much better privacy than pure. But it's, like the people made unrealistic claims about it. All Ivan's article really did was say, those unrealistic claims are unrealistic. Here's what the protocol actually specifies, which we all knew. Anyone who understood MimbleWimble knew right away how it worked,
Yeah, of course.
and what its limitations were. But yeah, it's just a
Yeah. It's
little
the way
history there.
the way it goes.
Yeah,
But
yeah.
yeah, so basically for like this Sniffer node thing seems to be a problem if there's especially too few transactions, but also too few nodes. And so if like 2/3 or whatever of all Litecoin nodes right now, and probably a larger share in the future, are already kind of supporting this, and that's not really that much of a problem if people are kind of trying to snoop on this kind of stuff.
Yeah, yeah, yeah. So the number of nodes really doesn't have much effect on the privacy though, because all it takes is one person snooping on the MWEB transactions and recording it. So you have to assume like anything you broadcast is recorded. So the only thing you can really do to improve it is one, to have a lot more people using it, a lot more transactions to obscure the history. But two is to kind of join your transactions with others before ever broadcasting them broadly. So it's like before, the coin join is done when creating a block. But if you want a coin join before that, you can go a traditional style, have a central server that has to be trusted, or you have to do fancy stuff to avoid the trust either way. But you have to have some sort of central server to kind of aggregate them. Or there's clever ways of like carefully choosing who you tell it, which nodes to tell about your transaction, or things like that. Or there's a protocol they implemented on Grin recently. It's called CoinSwap, and it's really cool. You still have a central server, but there's no trust involved in it, and you can like just send your outputs to it, and it transforms them and puts them in completely huge mixed list of other coins, to almost completely break the link between the original coins. Definitely, huge, obscures it quite a bit. So
Yeah. Well, that makes a lot of sense. So do you plan on any future MWeb development work, or is it just kind of there? Is there anything else that's cool coming down the pipeline?
So V24 has a lot of the major stuff we need that's been missing. It's got the PSVT support, so partially signed transactions. That'll be needed if any hardware wallets want to pick up MWeb. It's got the syncing changes and new peer messages that are to support like client syncing, so that hopefully we can get more mobile wallets involved and things like that. It's got view keys, which opens up the door for various like different whatever third-party services to use in various ways. But it kind of fills in, it is like the whole MWeb development. Normally that's like a $4 million team of 10 engineers and 20 talking heads or whatever, to put something like that together. But it was just me and a couple of the community members just kind of hammering away at the code. So there's a lot of stuff that would have been in like a VC funded kind of thing, that we just didn't have time for at the time. So we're
Mm-hmm.
kind of backfilling, adding the features. We got the core protocol launched. It's working well. So now we're just kind of backfilling the obvious missing pieces right now.
Mm-hmm.
And then, in the future, uh, I hope to implement coin swap or something of the sort to help improve the privacy some. But beyond V24, um, I have no big plans right now. Um, so
Yeah.
yeah, plenty busy as it is. So it's hard to take on more.
Yeah, absolutely. Well, cool stuff. Well, where can people follow you, and then also development updates and stuff like that?
Oh God. Well, on Twitter you can follow me. I don't know. I think David Burkett 38. When is
Yeah, let me recheck what it
yeah,
was.
38, either 38. David Burkett 38.
Yeah,
Um,
David Burkett 38.
yeah. So I did like monthly updates every month for 3 years, and then I
Mm-hmm.
fell behind, and it's been probably 5, 6 months since my last one. I keep
Mm-hmm.
saying every week I'm going to do one this week, and I haven't done it yet, but I will start at some point again. And you could just follow my Twitter or the Litecoin talk. There's like a forum post on there that you can follow for the not so monthly updates.
Yeah.
Um, yeah, yeah.
All right. Well, fantastic. Thanks for the chat, and it's been very enlightening. I hope you have a good one.
All right, you too. Thank you.